Chapter 9 deals with sequences in series. We'll also get into some probability things later and binomial theorem and that kind of stuff. A lot of this will feel like review from FS&T, except the sequences you're going to deal with are a lot more challenging. Not everything is going to be arithmetic and geometric. Okay? What's the difference between sequences and series, first off? Nobody?
I got it, but I opened my
I'd probably take a guess. Maybe ballpark it first.
Yeah, probably wrong. But sequence is literally just when you list out all the numbers. Series, you do what with them?
You don't list them out.
No, specifically, you just add them all up. It just means find the sum. They'll talk about sum of the series, or they'll talk about listing a sequence. Okay? They're just looking for a list of numbers. That's the sequence. Now, if it's a finite sequence, that's not too bad. And if it's not too many entries, you just list out those out. If it's an infinite sequence, well, you're obviously not going to list all those. The subscripts just indicate what?
Which number in the sequence?
Yeah, well, its position in the in wherever the sequence is. So if I have a sub n, what would be the previous number to a sub n?
A sub n minus 1.
A sub n minus 1, and the next number would be?
A sub n minus 2.
Well, the next one after a sub n would be?
N plus 1.
A sub n plus 1. Yeah. Okay? So, some of this will be as simple as write the first 5 terms. Now, how would I find the first term of that first sequence?
Put 1 in.
Plug in 1. So what type of expression does that make that, or equation? Starts with an E. Explicit. It's an explicit because if you want the 27th term, you plug in the number 27. What is the first term of the sequence? Next. So what type of sequence is this? Arithmetic, because you're adding 2 every time. Since you're adding the same number every single time, it's arithmetic. It's geometric if you're doing what? Multiplying by the same number every time. Here we're adding 2 each time, so it's arithmetic. For this one ends up a little bit strange. What's a sub 1 going to be in this case? 3. What about a sub 2? A sub 3? A sub 4? And a sub 5? 3. Thank you. Okay. Is that one arithmetic or geometric? Neither. It is neither of them. What about this one? What would be your first term here? Like I said, they get a little ugly looking after a bit.
1.
Just 1? Because it's actually, you end up with 1 over 1, right? What about for the second term? Yeah, you get 3 over 2. Next. One over 3. Fourth. 3/4, and fifth. 1/5. If you look at it, your numerator is that's almost the same as that equation up above, where you're alternating between 1 and 3. Your denominator is just increasing over time. Okay. Again, that would be neither as far as arithmetic or geometric. Questions on that? Okay. When you go the other way, it can be a little more challenging. Write an expression for the most apparent nth term of each sequence. Okay. So, if I want to write a sub n here, first off I want to look for any patterns. Are there any patterns on that first one? You're adding 4 each time. And make sure that follows through. If you notice on the first couple, it may still be there. Check it on the few after that as well. You're always adding 4 for that. So, how would I actually write an explicit equation for it? 4n? Do what? Plus 1? So a sub n is equal to 4n plus 1. So if I plug in 1, does that work? No. Yeah, you need to actually be 4 back from there. It needs to be minus 3. Because if you just start with the 1 there, it's not going to work. You need to actually look at the 0 state of it if you want to think of it that way.
Can you explain that again, please?
Which part of it? Why the plus 1 doesn't work?
Yeah.
Because if I basically just plugged it in, if I have plus 1 there, that's going to be 4 plus 1. My first term isn't 5. My second term's 5. So to compensate for that, I need to take what was plus 1 here and move it back 4.
Okay.
So if you subtract 4 from that, now if I plug in 1, it's going to give me 4 minus 3, that's 1. Plug in 2, 8 minus 3 is 5, and then it starts working after that. So always double check and make sure it works for the first few. Second one is a little more challenging. This one, you have 2, negative 9, 28, negative 65, and 126. Is it arithmetic? No. Is it geometric? Well, if you multiply by negative 4.5 to get to here, 9 times negative 4.5, will that give me 28? No. So immediately it's not geometric. So it's something else. First thing to do is honestly get rid of the negative. Or account for it anyway. What would I have to be able to flip back and forth from negatives to positives like that? Yeah, negative 1 to the nth. That'll deal with the negatives. So now I can ignore the negative signs. Okay? So I have 2, 9, 28, 65, 126. Are those increasing fairly quickly if you ignore the negatives? Okay? Any idea of something where you have a pattern where it starts increasing, starts off small but increases very quickly? Say again? Exponential of some type. Well, logarithmic is decreasing, but yeah. But actually, it's not quite exponential. It's really hard to see at first, but I see 2 and 9 how far apart? 7. 9 and 28 how far apart? 19. 28, 65? 37. Those are all primes, right? What if I subtracted 1 from each digit? Subtract 1 from each digit. So instead of starting with 2, if this was a 1, what would this be? 125. Anybody recognize it now?
That did nothing.
That did nothing?
No.
1, 8, 27, 64. I want a formula where I plug in 1 and I get 1. I plug in 2 and I get 8. I plug in 3 and I get 27. I plug in 4 and I get 64. Cubed. Raise it to the third power. Honestly, if you see numbers like 1, 4, 9, 25, or 1, 4, 9, 16, 25, 36, it's squared. If you see 1, 8, 27, 64, 125, it's cubed. This, you're cubing that n value. But you're not just cubing it, you're then doing what with it? Adding 1 to it. So if I put all this together, I get a sub n is equal to negative 1 times, or raised to the n, sorry, times n cubed plus 1. Are we good? Why not? What? Why? Why? Yeah, the problem is if I leave it like this, your first term when I plug in a 1 there is going to be negative. Well, up here my first term's not negative, it's positive. So I need to adjust this exponent. It doesn't really matter, you could add 1 or subtract 1, but you need to adjust it off by 1. So when I plug in 1 now, I get raised to the 0. Well, that's going to give me a positive on the first. So yeah, this would be your formula for that. Okay, these are the ones you're going to want to practice, honestly, during the work time today and tomorrow. These are the ones that are challenging. If they hand you the formula, say find the first 5 terms, those aren't bad. It's when they hand you the first 5 terms, you need to figure out the equation that can be a bit of a struggle. Especially when it's a pattern like this, it's hard to see. Yes?
Is there a program that you can just
Nope.
type in?
Not that's going to recognize that. Okay. Sequence. You can also define a sequence instead of those explicit formulas we just did. You can define it recursively. So in other words, in order to do it, you need to take a given value and then adjust from that given value. So the downside of that is if you want to find the 27th term, what do you need to know? The 26th term. Okay, that's why explicit is oftentimes better for that, but This is what your calculator does with iterations when you take the previous answer plus 5 and just keep hitting enter over and over again. It'll just keep adding 5. It's acting recursively. Okay? Well-known version of that's the Fibonacci sequence. Anybody remember what the Fibonacci sequence is? Nobody?
I remember what the graph looks like, but I can't remember exactly what it is.
How do you get the next term of the Fibonacci sequence?
Double.
No.
I can't remember.
You add the two previous terms, and you start with 1 and 1. 1 plus 1 is 2, so the first three terms are 1, 1, 2, then 3, then 5, then 8, so on and so forth. You just always add the two previous terms. So if you write that as an equation, if I want this term, I'm going to take the previous term, which how would I write the previous term?
Minus 1.
A sub n minus 1 plus a sub n minus 2. So I'd always add the two previous terms, but since it's recursive, I would need to also say a sub 1 is equal to 1, a sub 2 is also equal to 1, and then it builds from there. Then they'll also add on to this, n would have to be greater than 2. Would have to be an integer greater than 2. So that's what a recursive one will look like. But most of them are going to be fairly easy on this again because they're just going to ask you for the first 5, or they may ask you to use it to find the explicit, something along those lines, but we'll get to that more so later. This one's written a little bit differently. They give you a sub 1, then they ask you to find a sub k plus 1 equals a sub k plus 1. Well, the subscript and the regular one here. So your first term is what? 6. And yes, you have to list it even though it's given to you. A sub 2 would be what? 7. A sub 3? And keep going with it. First 5 terms. Now you also see them written like this in a sequence. You'll see a brace on the left and the right, and then just 6, 7, 8, 9, 10. Okay. The cursor's not too bad. Factorials. N factorial just means n times n minus 1 times n minus 2 times n minus 3. Keep going until you have times 4 times 3 times 2 times 1. Okay? And 0 factorial is 1. Yep. So if I want the first 5 terms of this sequence, but they do specify start with n equals 0. So I want a sub 0, a sub 1, a sub 2, 3, and 4. There's your first 5 terms. And then I want to graph it. What is a sub 0? So if I plug these in, 3 to 0 plus 1 would be what? Over 1. So this is 2 over 1 or 2. What would a sub 1 be? Yeah, you're going to get 4 over... Or wait, no, well, before that, just so people can see the patterns, honestly. You end up with... oh wait, yeah, it would just be 4 over 1. I'm sorry, I'm getting ahead of myself. On the next one, what would you get? Top and bottom. Say again? 10 over 2, so 5. So this thing's just going to keep increasing, right? What do you get on top for the next one? Over? 6. Because you have the 0 there, 1 here, 2 times 1, and then 3 times 2 times 1. What about for the next one? 3 to the 4th is? Plus 1? Over? Well, you already know what 3 factorial is, so just multiply by 4 and you get 24. So this simplifies down to, and this simplifies down to 41 over 12. This is just, you just multiply 3 times 2 times 1. So this denominator, I'm plugging in this 3, that's 3 factorial. For 4 factorial, you just do 4 times 3 times 2 times 1. Okay, so that's the 6 here and the 24 here. Then when you simplify, now if I go to graph this though, well, did we keep increasing? No. So at 0, we were up here at 2. At 1, we were up at 5, or 4, whoops. What if I graphed it right? We were up at 5, 4, 3. Where's 14 thirds going to be? Say again?
A little.
A little over 4. And 41 over 12? A little before 4. Now, would I draw the line connecting those? No. They're asking you to graph the terms on the set of coordinate axis. So they're asking you to graph those individual points. They're not asking you to draw a line. Connecting them would actually be incorrect. Okay. Evaluate the factorial expression. So without the calculator, what can I do to make 9 factorial over 3 factorial, 7 factorial easier to do without the calculator?
Write it out.
Yeah, 9 factorial is 987. And it keeps going, but we can stop it there because that'll allow me to do what? Yeah, you have 7 factorial over 7 factorial, those cancel. And 3 factorial is just what? 6, or I can actually just write it as 3 times 2, and I don't care about the 1, right? Well, what do the 3 and 2 simplify with? Yeah, the 9 and the 8. 3 and 9 simplifies down to what? 3 and 1. 8 and 2 simplify down to 4 and 1. So that's just going to give me what? 12. Everything else goes away.
So are we gonna have to like show the work like that?
Honestly, I'm trying to lean us towards this third problem, which you couldn't do on the calculator. This one, and honestly the second one you could do on the calculator. The third one up there you can't. Okay? So let's just jump to the third one here. N plus 1 factorial over n factorial. What would I do there? Yeah, you got n plus 1, because that's the next term, times n factorial. Well, not just all the n's, but all the n factorial. N and everything smaller, right? So you're left with n plus 1. If I had 27 for the term here, this would be 27 times 26 times 25, right? So n plus 1, the next number smaller is just n. Does that make sense? That loses some people sometimes, so everybody's good though? Okay, good. And that one, obviously, you can't use a calculator on. Summation notation. Sigma, in other words. Okay. This book will refer to the index of the summation. They just kind of start throwing more math terms at you. Sigma notation or summation notation. The index is just this I value here. Whatever you're using as your variable, that's your index. Then you have an upper limit and a lower limit. Lower limit's down at the bottom, upper limit's up at the top. And then your sequence is going to be based off of what that progression on I is and what you're doing to it. Okay? So, down here, now they keep the numbers fairly small. All the calculators are capable of doing these, but depending on how old it is, you may have a very easy where it gives you the sigma, or you may have to actually go into some of the menus. Does anybody know how to do this first one? Actually, let's just do this first one by hand real quick. What's your first number? Yeah, it'd be 4 times 1 plus 1 is so 5. What's your next number? So when I add those up, what am I going to get? We're okay. Hold on a second. We're just taking the 1 here, which is what I is, and putting it in for I. Then we're doing everything from 1 to 4. So you're plugging in 1, plugging in 2, plugging in 3, plugging in 4. So what do you get? 44. Okay, so you get 30 plus 14. Here, let's put this one in the calculator. Okay, should leave myself some room. Now, the newer calculators, where is it at?
Oh,
Math, scroll, honestly go up a couple, summation will be right on there. Now, if you have an older one, the problem is it's not there. So we need to do something a little bit different. If I go to math, I got nothing down here. Okay? So, if you have that, great. If you don't, what you end up having to do is this process. I'm going to go second and stat. Okay, then I'm going to go over to math, and I'm going to go down to summation. Okay? So I'm going to put sum there. Now I need to sum a sequence. So I'm going to go back to that same second and stat, but now instead of math, I'm going to go to options. Fifth one down is your sequence. Okay? So you do that sum and then sequence. I'll write it down later if you want. Anybody have a calculator this old before I go through the whole process? Okay, just checking. From there, and this will work on the newer calculators too. It actually brings up a different menu for it, but it will work. I want to put in the equation. So that's going to be the 2 plus k to the third, or the expression. In this case, x raised to the third. And I'm going to separate out with commas, and I need to tell it everything that's going on in this formula. So I'm going to tell it the variable first. I'm going to put an x. I define what variable I'm using. Then I do another comma. The comma's right above the 7. And then I put in where I'm going, taking that x from what to what. Well, I'm going to go from 2 to 5. And then I want how big are your steps is the last thing. I'm going to go by 1 each time. Okay? So you have your sum sequence, then your expression, your variable, where you start, where you stop, and your steps, how big they are. Close out the parenthesis. What do you get? 232. Okay, and that works on the newer calculators as well. So sum, they're both inside the stat menus, and then sequence. And then your expression, whatever that is. Your variable, first value, last value. And then your steps, honestly, they're always going to be 1 for this. You could conceivably go up by more than that, but it's never going to happen. So go ahead and find C. Go ahead and find the last one there. What do you get? Oh, I was actually just thinking of the decimal, but 3.4 what? And then 1 repeating? Is that what the fraction is? I don't know. Okay, that's fine.
How it automatically
Do you want it
That's
in
fine.
decimal?
Either one. I'm not going to be that particular on it. Okay. Basic properties of those summations, you can split them up. If you have the sum of a constant, so if you say the sum of 7 as it goes from 1 to 6, that literally just means 7 plus 7 plus 7 plus 7 plus 7 plus 7. If it's just a number in there with no variables. If you have a variable, if you like, you can actually remove the constant first, figure out what that summation is, then multiply by that constant. Since all you're doing is adding a bunch of numbers in a row, you can split them up. Subtraction, same thing, as long as you subtract the sum of the second part. Okay. Series, you can actually have a couple different varieties. You can have the sum of an infinite series, or you can have the sum of a finite series. Now, a finite series is also called a partial sum. They talk about finding the 5th partial sum, it just means you find the sum of the first 5 terms. Okay? So you just go through that process just as you would otherwise. Now, without the calculator, let's look at this one. The sum of this infinite series, but I want the third partial sum. Okay? So then I want to figure out what are your terms. Well, what's your first term here, your second term, and your third term, and then I want to add those up. What's your first term? Yeah, 1/2. What's your second term? Yeah, 1/20, because it's going to be 5 over 100, so 1 over 20. What's your third term? One over 200, or 5 over 1,000, yep. Okay? Now, that can be kind of hard to see what they're adding up to, just looking at that. Sometimes it actually does help to turn them into decimals. What's a sub 1 as a decimal? 0.5. What's a sub 2? 0.05. What's a sub 3? 0.005. So your first partial sum, or the third partial sum I should say, is just 0.555. Okay? Now, what about if I run this to infinity? I want the sum of all of them. It'd be 0.5 repeating. Well, what is that as a fraction, though? 5/9. So it would actually sum to 5/9. Questions so far? Okay. Two more real quick. For this, a deposit of $1,500 made into an account that earns 2.5% interest compounded monthly. Balanced in the account after end month is given by this formula. Write the first three terms of the sequence. Well, what's the first term of the sequence? $1,500. Yeah, so a sub 1 is 1,500. Go ahead and find the next two. What do you get for a sub 2?
1,503.155.
So since we're talking dollars and cents, I'd probably just put 0.13. What's a sub 3?
No.
Yeah, okay, I
Go
mean,
ahead.
a sub 1 is actually what you have for a sub 2, and a sub 2 is
Yeah.
1506. Because when you make that 1, it doesn't cancel that out.
Or is it backwards because it's just.
Yeah, because it says after n months, because a sub 0 would then be the initial balance.
No, so I should actually label that as a sub 0. But the first three terms of the sequence, the balance after n months, so you actually would classify that as 0 months. Like, what's your initial value? So if you think of, that's the problem with a sub 1, sometimes you think of that initial value, you're right. This should say a sub 0 because of that.
So if we go up. Okay, so then a sub 2 is 1,506.
Yeah, 1506.
0.2.
Yeah, I should have labeled that a sub 0, you're right. But that is still technically the first term in the sequence because you would start with that much initial value. Okay? So if I want to find the balance in the account after 4 years, go ahead and find the 48th term in the sequence.
1,657.55.
Everybody else get that?
Yes.
Okay. Not too bad. Honestly, most of the word problems in the first section will be fairly easy like that. Some of them might be a little tricky. Something like this instead. Number of employees in a physician's office from 2002 to 2007 is given by that polynomial. The number of employees, where a sub n is the number of employees, n represents a year. If n equals 2 corresponds to 2002, find the last three terms in this sequence, which represents the number of physicians' office employees from 2005 to 2007. So what are you actually looking for here? What terms?
5, 6.
5, 6, and 7. So a sub 5, a sub 6, and a sub 7. Go ahead and find a sub 5 for me, using the formula they give you.
2000.
Excuse me. Say again?
2095.
Anybody else get that? Does the answer make sense?
Well, because it ends now.
Yeah, it's in thousands. We're talking about the number of employees in doctors' offices, right? So yeah, it does need to be 2 million and what? 95,000. Okay. So 2,095,000 employees. What about 2006?
2,147,520.
500 and what? 20 employees, and for 2007?
2,205,080.
Make sense? Yeah, watch out on word problems for terminology like that. Make sure you actually give the entire answer. Okay. We still have a good 12 or so minutes left. Do some of those problems. Honestly, they're on the second page and some on the third page where they give you the sequence of 5 numbers and you need to write the equation. Practice some of those in the next 10 minutes.